Okay, it's 11/2, depending on your time zone. So we'll get started. So thank you for everyone who's joining. This is the Connecting Informatics to Science community session. Basically, we're going to talk about how all the great work we do in ESIP should be integrated. Like, how do we bring all the great work we do in ESIP to the various science communities? Because they're realizing they need this information. They need to know how to do work with APIs. They need to work, with things like schema.org, but they don't know what's called schema.org. They need to, help bring open science to their work. And I feel like ESIP does a lot of this, but it needs to get out. So how do we do that? So let me share my slides. Let's see. Okay, I think you're seeing my slides.
We're not seeing them full screen. Oh, now we are.
Yes.
Okay, and it's the right screen, right?
Yes.
Okay, cool. Okay, so like I said, connecting informatics to science communities. Of course, logistics. Hopefully you're on Schedule. There's the link to this key code chat, and you can get to the main Google Doc from there. And there's a bunch of links in there which will be useful for later on. Also, if you can add your affiliation next to your name in Zoom, you can just go under the participants list, and then if you hover over your name, there should be like a little thing that I think 3 dots, and then you can click rename, and then just add your affiliation to the end of your name. I have created a Slack channel under ESIP All, and for Informatics to Science, so we can continue the conversation after this session to figure out what the idea is. We'll come up with some actions at the end of this, and what should we do with them. And so that's going to be kind of our venue for communication until we solidify things more, whether that is we bring our actions into other groups within ESIP, or do we need to actually form another group. I would prefer not to create more groups if it's really concepts that are being covered by other ones, but there might need to be one. So that's one of the things we're going to figure out. After the main presentations, we're going to break everyone up into breakout rooms and basically, kind of discuss what's gone on with the lightning talks. And there's also some conversation starters. Don't feel obligated to answer those questions. They're just to kind of help, start a conversation and get the ideas going. If your group already has ideas, that's perfectly fine. Totally go with it. The link to the slides are linked in Schedule and in Kiko. So you should be able to get to those. Okay. So the main purpose of this session is to get informatic organizations like ESIP. There's also some other ones like CoData and RDA, but this is the ESIP summer meeting. To develop recommendations and improve the usage and understandability of new technologies, and moving forward the standards and conventions of whether it be metadata, APIs, ontologies. We do a lot here. And most of us have science backgrounds, or we work with scientists, so that we understand these are the things that people can help. These are the things that will help people and researchers do their science better. A lot of what was talked about in the plenaries this morning. But how do we integrate those things into the workflows of those science researchers or application people, whoever that end user is? How do we convey that to them? And scientists, of course, realize that these technologies and these kind of workflows sort of exist, but they don't know what they're called. They don't know where to go to. They don't know what their resources are. So how do we bridge this gap? How do we bring informatics and science closer together? So first, we'll start off with some talks. I'll be talking about giving a summary of my breakout session at Oceanogs, data integration to user products, which kind of talks about this in a oceanographic specific view. Ed Armstrong's going to talk about CIOS AnalysisReady Data for the oceans. Megan is going to talk about the help desks at the various scientific meetings that ESIP supports. And Stacy's going to talk about Ocean Hack Week, which is kind of like, a way of doing. So that'll be interesting. So I think I'm just going to go into my talk unless anyone has any questions about what's going to happen in the rest of the session. Nope. Okay. I also can't see the comments, so I apologize if people are posting comments and I'm not responding to them because I'm in my PowerPoint slide mode.
Jessica, we'll let you know if there's anything in there.
Okay, thanks. Okay, so I'm going to talk to you about the Oceanogs 19 data integration for user products breakout. So Oceanogs is a decadal meeting that happens. It's a community-driven meeting to help with the observations of oceans to understand the science and the societal needs of the oceans. So this meeting happened in September last year in Hawaii. And I know some of you that are in this session were at the meeting, and you were at my breakout, so thank you. This is also the first time this Oceanogs had data and informations as a theme. It's been mostly like observing platforms, science, various integrated international networks, but they actually had, they recognized that data is a challenge, and how we deal with data helps with how people are able to do their research. So there were multiple, so this is a theme with multiple breakouts associated with it. There were 135 community white papers, and there were 10 themes to this conference. They're all available, so you can peruse as much as you want. And there are multiple informatic papers written for this Oceanogs, and some of them are pretty interesting. So I suggest if you haven't already looked at them, take a look. So the breakout session I had is basically about how data integration can be done to user products. And a user product can be anything from an analysis tool to being able to generate higher level products so that it becomes easier to use. So either on the tool side, analysis side, or creating new data. So basically, how do we have data products that are enabled to have the native original data sets, but they also need to have well-crafted management plans. They need to be fair, with the acronym. I think we're all familiar with that by now. If not, please ask the question, because there's a lot of work's been done with it, and don't feel bad if you don't know about it, because a lot of people still don't know what's out there. So you need to have fair data. You also need to know what the data quality is, because depending on your application, poor data quality can almost make your project non-existent. And you want to know that before you start investing a lot of time. Also, if the data are well formatted, they can be exploited by open source software and APIs. And then there are multiple informatic organizations that exist that have best practices and recommendations on how to leverage, on how data can be leveraged and how they can be best produced by the data producers of ocean observations. So the recommendations that came out of this group were that funding agencies of ocean observing systems need to align funding to meet the demands of data management, long-term stewardship, and training. And this is a case where we don't want to reinvent the wheel. There are groups like ESIP, CODATA, RDA, IODE, E2SIP that are working on this, and so this is where this bridging happens. We don't want the science communities going off and like, oh no, we have to figure this out. Let's figure it out, when a lot of work's already been done. We also need to qualify user products, quantified measurement uncertainties. It should be added to the measurements as they go into ocean observing systems. And this is a thing where modeling communities, they really need to know what the errors are. If you're going to make higher level products, you need to know what the data qualities are, so you don't perpetuate bad data, whatever bad means to you and your community. And data providers should also strive to use web services and well-described and open APIs to distribute their data and make them human accessible and machine readable to enable data products downstream. So this could be, your analysis-ready data, whether you're producing analysis-ready data or you have your data well formatted so that you can put it into an API or a web service that will provide a service that almost makes the data ARD or analysis ready. And there was also a follow-up meeting. So the idea is like Oceanogs is not going to just end. We're just going to magically do stuff 10 years from now. The idea is they're going to have continuing meetings associated with ocean sciences and AGU. So just the day before ocean science meeting, we had our research coordination network. And so the idea, and so what happened is all the breakouts basically run over what the suggestions and results were of their session and how they're going to continue with that work. So for this breakout, the one thing we want to do is provide a guidance document for funding agencies on things like how do you educate on informatics, how do you bring that in, define core competencies in ocean data science that are necessary. And we want to do this on the grad, if we can get the students to do this, then, this is the future bringing us in. So get the concept of you need to know how to deal with data. You need to know how to manage data to a certain point in early. And then also build this bridge between technology and science, because I don't know about any other discipline that still uses things like Fortran. All the computer science graduates we've had at Podak, they're like, you still teach Fortran? Why are you still using Fortran? Not that I'm digging on Fortran, but it's an example of there are new languages out there, there's new technology out there, and it's very slow to be ingested into the science community. And it could, it makes things more interoperable, because now you can have science or computer science programmers help you with projects and bringing in those newer technologies at a faster rate than what we currently do. Okay, and then I'm gonna stop sharing. And Ed, I believe, is next, and he's going to talk about analysis-ready data in CEOS.
Thank you, Jessica. I'm going to go ahead and share my desktop here and get my presentation going. Okay, there we go. Hopefully you can see that. So I'm going to talk about CEOS analysis-ready data for the oceans. And again, I'm Ed Armstrong. I work at the NASA Jet Propulsion Laboratory, the Podak, one of the 12 NASA data centers for Earth science. And I'm going to talk to you not just from the perspective of the Podak, but I've been recently more involved with the CEOS organization from the perspective of I'm a co-leader of the SST virtual constellation. And I've been attending actually my first kind of CEOS activity or meeting last March, the strategic implementation team meeting. And they have been looking and are developing analysis-ready data. And so if you don't know about CEOS, I don't seem to be able to advance my slides here. There we go. Okay, CEOS is the Committee on Earth Observation Satellites. It's an international consortium to coordinate and foster Earth science satellite observations. So it's truly international in scope. It has over 60 international members managing over 170 space assets, if I can remember the things that were written on the website this morning. So my talk is going to be basically, I'm going to start off with an ARD definition, and this is kind of my own independent definition. Some of the audience might have some other takes on ARD, but it has been presented to the CIOS leadership and or the SIT leadership and more or less accepted, so that's a good thing. And then I'm going to move into some ARD activities in CIOS. There's this card for L that I'll describe a little bit, and the CIOS Coast Initiative, and then talk about what the ARD for oceans might look like with regards to sea surface temperature and ocean color, and some of the things I'm interested in working on to come to have it become available. And as well as I'll touch on a working example of a level 4 SST that you probably heard about earlier this morning, and Shell's talking with some closing thoughts. So, here's a short and sweet definition of analysis-ready data. It's really a time series pre-process for further scientific and interdisciplinary analysis. And it's ready for the whole spectrum of time series analysis you might want to do, as well as subsetting, regridding, reprojection, recombination, reformatting. And it's ready for these new compute platforms on the cloud and no SQL databases. And it has been processed or pre-processed for calibration and then environmental corrections right down at the pixel level. So the user doesn't need to deal with those types of tremendous pre-processing issues that are really necessary to do science with Earth data streams. And so it's available in some kind of big data format that could be ZAR, that could be the cloud optimized GeoTIFF. We heard a lot about these earlier in the week on Tuesday. There were several sessions kind of documenting some of the latest uses in our community of these big data formats. And then also importantly, there should be some documentation trail for its processing quality and error assessment. And the thrust of this is this ARD definition is really separate from the kind of the deployment of the ARD. So I realize to use the ARD, it has to be kind of the complete package. You have to have it on some new compute platform. But I prefer to keep kind of the foundational specification of the ARD separate from a deployment or a service. All right, so the card, what has CS been doing in the ARD? They've been actually working in this arena for about a couple of years now. They actually came up with this specification called CIOS AnalysisReady Data for land. So that's the card for L acronym. And it's really right now a specification document for land, surface temperature, surface reflectance, and radar. They do have some working examples. I'm really not the best kind of spokesman for it, considering I've been somewhat new in the kind of the CIOS hierarchy. I've only been working with the CIOS organizations at this level as the co-lead for the SST virtual constellation for 6 months. But they have developed this document that does describe the necessary requirements on the general ancillary metadata and also all the geometric and radiometric calibration at the pixel level. So and that has been published in different documents over the last kind of like year or so. And they have already working with like stakeholders like Digital Earth Africa, and there's a group now in Australia, the Geosciences Australia, that has really done some really advanced things with regards to the ARDs that are available out there. As I'll refer to later in the talk about some of the ARDs that are on the Amazon Open Data Registry. They've kind of like built a kind of a unique ecosystem for that, and are working to kind of publish the interface to that. That's part of the CIOS interoperability lab that should be available soon. Okay, so importantly, also for this, they've also published or have a separate product and peer review ARD assessment process. If you want to learn about that, there's the URL. So the other activity with regards to ARD, there's this new CIOS Coast initiative that wants to look at remote sensing applications to work on environment management and response problems at the land-ocean interface, or looking at both the land to the sea effects and the sea to the land, looking at a number of different kind of cross-cutting data sets, and have are putting forward a lot of requirements for data sets that would be more useful if they were in ARD format. So they're kind of like a driver. This is also very kind of a new activity. They're about 6 months into like kind of a 3-year project. So the idea is to build a pilot project where these data sets and tools and services would be available for specific regions in the world. Some of these are like, as you see down here, are small state island states that have like corals and mangroves, but it also looking at large scale urban centers too, and large scale coastlines as well. There's also a website for that I can point you to later. So that's one of the drivers for ARD, especially for the oceans. And so where I'd like to focus in is, the likely candidates for ARD. From my perspective, I'm a little bit biased here. I've been working in SST for decades now. So SST, of course, is near and dear, but also then ocean color. And so, of course, at the data set level, there's various different processing levels, 2, 3, and 4, with different degrees of data complexity, various levels of pre-processing quality and certainty information. So how do you look at that kind of horizon and that spectrum and look at what is necessary from the foundation level to build an ARD? So I've been active in the group for high resolution SST, which represents a resource of over 100 international SST data sets at these different processing levels, and they're all neatly packaged in self-describing NetCDF formats with commensurate pixel uncertainty and data quality. And the question I'm trying to look at is how amenable are these data sets to our ARD from the perspective of their data and metadata structures? I think I know part of the answer to that, but I intend to do a small survey of some of the more popular risk data sets to help answer that. Is the available quality, uncertainty, and other information really enough to kind of develop cleanly and transparently an ARD and put some practical examples to be built? So actually, an example has been built, and this was at the level 4 level, and you heard about that in Shell Intiman's talk about the AWS level 4 near ultra high resolution data set that she built in the Pangea ecosystem. So that's a great data set. It was part of the Open Data Registry. You can go to the URL right there. She's built some binders that you can launch right away, and the complete kind of Pangea ecosystem is available right out of the box there from the get-go. Built on Xarray and Dask. So this is all run smoothly in this Jupyter Notebook that you launch with the binder interface, and allows you to do some very complex operations on this very large SST mirror data set. And the nice thing, of course, is that all of these compute credits are provided by Amazon. And so for right now, you can do this for free, right? I think I was in another session where somebody raised the issue of all these freebie things could eventually evaporate as these large private companies intend to monetize the compute structure and the software platforms. And we should worry about that and make plans for that. But right now, it's free, and so we should exercise use what's available right now. And so here's just a kind of a snapshot of the Jupyter Notebook that has been built, where you can do all kinds of manners of time series analysis, build climatologies, do SST anomaly. This is really kind of takes place in the spectrum of minutes versus hours, as Shell alluded to in her talk this morning in the plenary. Okay, I think I'm wrapping up here. A couple more slides here. So I did mention for sea surface temperature, of course, ocean color is another ARD candidate. It's more challenging due to its really increased complexity and flags and uncertainty and error sources. It's really a more difficult type of remote sensing measurement to work with, and SST has its own kind of sets of complexities, but it could really benefit from a similar approach as SST, kind of looking at what's out there on the level 2 data sets, how they're built, and what information really would be need to leverage to build a proper ARD. So then the good thing is the number of sensors you need to look at is less, right? I mean, some of the likely candidates are CWIFs and MODIS. But if you did do something, so had these 2 ARDs, ocean color and SST, it would really be fantastic because for them to interoperate. I could see all kinds of great new science that people would be able to do on the global and regional scale. And as an example of this, there have been some data sets, gridded data sets developed by the CEOS coverage activity that Barda Santos, who held a CEOS coverage workshop yesterday, alluded to. But I'm thinking at the lower processing level, level 2 or level 3, where more hardcore science is taking place at the very high resolution, but those processing levels afford the user would be the place of doing some really great new science. Okay, here's just some closing thoughts. I think got a minute or two left here. So, this CEOS Coast activity will develop or leverage some of the land ocean ARDs. There's some working examples that I alluded to that are in this CEOS interoperability lab that's not quite public yet. But from my perspective, I'm interested in developing some more workflows, tutorials for Ocean ARDs, and hopefully, developing some like ARDs based on, say, the Modus Aqua or the Modus Terra L2P crystal L2P data set that was recently reprocessed and allows for a much more usable cloud-free pixels. I'm also convening a ARD Ocean session at this CIOS technical workshop, so that's the next international meeting in September 2020. Just, the card4L is really good. It actually presents a roadmap for really what I want to do. It's a recommendation strategy and a requirement list for building ARDs. And I tend to use it for like what I want to do for these GRIS data sets. It's a different discipline, of course, SST versus land and radar surface measurements, but I think there's a lot of what they have done that I can build on. And they do have this product assessment and peer review process of the ARD. And I don't really know too much about it, but it's maybe something that we need to think about in our emerging kind of ARD community or cloud community here at ESIP. What kind of community assessment process is needed for these data sets that come online? Of course, we can't build ARDs for everything, at least not right now. So as we kind of pick and choose the likely candidates, is the ones that most used in the community, or are there other kind of factors or metrics that go into that assessment process? All right, I think I've done my 10 minutes, or maybe a little bit more, so I'll go ahead and just stop right there. Thank you.
Thanks, Ed. So yeah, if you could stop sharing. There was a question that came in, and I don't know if you know what the link is, or I think I can find it too. If you know what the link or the citation is for like the actual technical details for the CIOS ARD.
Yeah, I can post a link to the paper here. I think that's what they're asking.
Yeah.
And so yeah, you have to read the paper to kind of determine how this particular land community at CIOS came up with what is necessary for an ARD. So I think it's pretty all-encompassing, but you'll have to take a look. I'll go ahead and do that.
And if people have questions about like bringing in more of an ocean-focused ARD, can they talk to you about that, and you can bring that up to CIOS?
Yes, yeah, certainly. Yeah, I'm part of this CIOS Coast initiative, and so we're kind of just right in the inception of defining which data sets we want to look at, right? We're doing a lot of like mining in the community right now, and so if there are like likely candidates that people are interested in, it'd be good to know those.
And then I think, yeah, we've got a couple minutes, Karen, if you want to, we're running ahead of time, so if you want to have a question.
Okay, thanks. Yeah, thanks for the presentation, Ed. I had two questions. One is, do you have any sense of how painful it was to develop this ARD definition? And second, any sense of, I mean, it sounds like it's a pretty hard specification. There's some things like FAIR where they kind of give a guiding principle, but there's still a lot of flexibility on what does it actually mean for implementation. It sounds like this is a pretty nailed down one. Is that accurate?
But to be fair, I wasn't involved in the process. It kind of predated kind of like my tenure in CIOS. Really, like the beginning of this year is when I started to actively assume this leadership position in the CIOS community. And they've been working on this specification since 2017. Look at the track history on the document and stuff. So it was, pretty, a long time, right, to write a document. I think it's pretty embedded, and it's pretty thorough.
Hey, Ed.
Thank you.
Oh, sorry, Ted. I'm going to move us along because Megan has her talk next. But these are all types of things. I mean, the breakout ideally is to have an action item at the end, but if your breakout happens to evolve more into like this CIOS talk, maybe you can have Ed in a breakout room specifically with CIOS questions. Okay, so next is Megan Carter, and she's going to talk about the data help desk.
Okay, am I unmuted and you see my screen?
Yes.
Okay, great. So hello, everyone. My talk's a little bit different, but I'm excited as ESIP's community director to talk to you about the Data Help Desk, which is a collaborative activity of ESIP, EarthCube, AGU, and EGU, as well as many additional partner organizations. I see many people on the line who've taken part in this, and I'm excited to see you here today. I've personally now helped to organize and execute 5 Data Help Desks, and I have some observations based on those experiences to share with you today. So the Data Help Desk provides researchers with opportunities to talk with informatics experts who are familiar with their scientific domain, to learn skills and techniques to hopefully help them further their research and to make their data and software more open and fair. This is a picture of an in-person Data Help Desk within the exhibit hall at a scientific meeting. You can see the setup. There are roughly 2 sections, a place to ask questions and pick up resources, and a space for help desk experts on the right to demo tools and provide tutorials. And as you might imagine, it can get very busy. So this is a photo of the demo part of the Data Help Desk at the 2019 AGU Fall meeting, where you see an ongoing demo about how to find an appropriate data repository. Individuals who staff the Data Help Desk, they do so on a volunteer basis, and they represent a wide range of organizations and data communities. So this is an example of volunteers and topics covered on just one day at the Data Help Desk at last year's AGU Fall meeting. Here's another excellent photo from the 2020 Ocean Sciences meeting, where this just gives you a sense for how busy it can get and how activities can spill over into the exhibit hall aisles and really be very attractive for folks to come over who weren't necessarily trying to end up in that space. So the last 3 Data Help Desks have included over 100 experts on call from 5 continents, and they have collectively many years of experience. We also conservatively think we interacted with over 400 researchers through both the in-person AGU and Ocean Sciences meeting events, the last 2 in-person help desk events. EGU 2020, Sharing Geoscience Online, was our first engagement with EGU as an additional partnering society, and it was our first virtual Data Help Desk. So as you saw in the photos, all of the help desks prior to that had been physical events, but this move to a virtual help desk helped us to realize new possibilities. So we ran the event largely on Twitter by posting questions and sharing resources with the hashtag Data Help Desk. We also had a few partner organizations who held virtual office hours, and we showcased over 20 contributed pre-recorded demos and tutorials. So the virtual event was a great opportunity to recruit a wider range of volunteers and to engage with many more people, since geographic location was no longer a barrier. Total questions at the virtual Data Help Desk this past May asked by researchers were fairly low, but still a lot of information and resources were shared, and a lot of Twitter activity was seen. So here you see there were over 400 posts using the hashtag Data Help Desk, 177 unique people who used the hashtag in some way, over 1,100 people who had an intentional interaction with a tweet containing the hashtag. They either liked it or retweeted it. And our reach and impressions were much greater, but you should note that those numbers have more to do with how many people could have potentially seen posts containing the hashtag rather than helping us to estimate how many people actually did, and especially not helping us to know how many people benefited from what they actually saw. So we have to think about, how can we track some of these more meaningful metrics beyond what Twitter makes easy to track. In terms of questions we typically get at Data Help Desks, we get some very general questions, especially from people who sort of stumble upon the Data Help Desk more at the in-person meetings. And we get some very specific, very specific questions. For the in-person events, we get a lot of people curious about what is this whole thing. They see the beautiful backdrop and kind of just come over and ask general questions. Often they'll ask about the organizing institutions listed on the banner. What is this all about? Sort of general questions. But then once folks catch on to what it is, they typically will ask, well, where can I find this very specific type of data? Where can I deposit this very specific type of data? We also have a lot of conversations about what FAIR means, and a lot of people don't know. Other less common questions, what about model or other large data? Questions about data storage and data analysis. What about my code or my software? We do see some people asking about data management plans, and there are occasionally some folks who are excited about bringing more data management standards into their communities. They see other communities doing things well and want to help align their own communities. And I especially like talking to those folks. In 2018, Wade Bishop and Rose Borden, who I saw on the call today, observed 2 data help desks, and they conducted a survey of those attendees who asked questions. So they asked what question the person had, what level of data management training they had, what their level of satisfaction was. And what they found is that 70% of researchers surveyed had no prior training in research data management. So they recommended that we need to have very basic materials available on what data management is. I've observed this also, seen a lot of interactions with students and early career folks typically. There was a high level of satisfaction with the help that was received, and this also led them to say, well, why is this limited to just the in-person meetings? Why can't this be a year-round service? From my perspective, there are a lot of challenges and opportunities associated with this event. We're still at the stage, as I've observed, of getting people comfortable with data management practices and what FAIR is at all. We talked to so many students and early career researchers, so I think we need to be especially ready to talk to them and to provide more visible evidence of the benefits of good data management practices, and not just the benefits, but the benefits of doing so early on in the research workflow. So not just when you want your paper published or when you need your funder to give you more money, but why really should I think about this at the outset of planning for my scientific endeavor. Another challenge is that those who have specific questions often have very specific questions. And it can be hard to be able to handle both the very general questions and the very specific questions quickly. So being able to process and being able to share a workflow for, I can't answer that right now, but but I'll get back to you, or I'll have somebody get back to you. You have to be ready for that. In terms of publisher and funding messaging, we know that sometimes requirements can be varied and confusing between them. So there are many different potential resources to point out to folks, and it can be hard to keep track of all of this for these events. Also, timing-wise, people have other places to be. Scientific meetings are really when they want to get a lot of other stuff done. So what other opportunities do we have to reach scientists? Specific to the virtual events, it's hard to have more serendipitous interactions. You know, people don't, as far as I know, or it's hard to know, kind of stumble upon the data help desk booth and start interacting you when they hadn't planned to show up there. Twitter is a challenge for some, both on the volunteer side and on the scientist side. I need to learn how to use it better, how to take advantage of it more for this purpose. And then we talked about this, measuring engagement is hard in the virtual environment. Yeah. So on the positive side, keys to a successful data help desk. I've seen this dedication of a core group of organizers. The Marine Data Cluster, ESIP Marine Data Cluster was an excellent example of this. Having a diversity of volunteers, both in terms of the organizations and the topics they can speak to, and thinking of it as a crowdsourcing event. So valuing a diversity of perspectives, a diversity of potential leads over finding the ultimate answer for somebody. I think having a solid communication plan, having strong support from the host society if these events are in conjunction with a scientific meeting, having them help with the promotion, as well as finding advocates, people who are in the scientific sessions and sections, and having them talk about these things. Clear and attractive signage, that kind of thing really does go a long way. And I have noticed that smaller, more narrow scientific meetings, well, Ocean Sciences versus AGU, tended to have volunteers and attendees that were a little more cohesive. And I think that was a result of being able to anticipate a little better what the range of potential questions could have been. We also just had very fantastic volunteers for that event. But there's something there I want to explore a little further. And then I think we talked about this. Most of us have scientific expertise. So talking about our own scientific background as a way of kind of developing trust with the people that we're talking to. So I found it useful to talk about some of my own data management challenges and how I've approached those. I find myself constantly promoting the role of data repositories and how useful they can be from the planning phases of a scientific endeavor. Those are just some things that have been rolling around in my mind since taking part in these events. So finally, I just want to say that data help desks are being planned in conjunction with GSA and AGU, both virtual events. It's a relatively low time commitment if you haven't been involved in the past. If you have something you want to share or you have an idea of how to make this better, I want to talk to you, so please get in touch. And thank you to all of the participating organizations and sponsors, and to the organizers for letting me speak to you today.
Great, thanks, Megan. That was a lot of really good information. We do have a few questions in the chat. I will let you answer those in the chat because I'm going to get us going on Stacy's talk, and she's going to talk about Ocean Hack Week.
Hi, everybody. I'm not going to present any slides, but let me throw a link to Ocean Hack Week into the chat. Great, hi. I'm Stace Beaulieu, and I'm a senior research specialist at Woods Hole Oceanographic. And we have about 1,000 scientists, engineers, and students at WHOI. And I coordinate WHOI's Ocean Informatics Working Group. And I'm information manager for the Northeast US Shelf Long-Term Ecological Research, or LTER, and that involves a number of universities in the Northeast US. So to link back to Megan's talk, I've participated in a couple of the data help desks at AGU and Ocean Sciences, and I also run WHOI's Data Science Office Hour every week. And I want to say scientists and students have questions relevant to every step in the data lifecycle, from creation to analysis to publication to reuse. And to relate back to Ed's talk, to create analysis-ready data. So at WHOI, our Ocean Informatics Working Group has specialists in all steps of the data lifecycle. And again, to connect back to Jessica, we call ourselves the bridging team. So we bridge informatics and the sciences. And as part of our efforts to help with data analysis workflows, we offer workshops to help our staff and students learn the foundational data science and software development coding skills. For example, we're a member of the organization called the Carpentries. You may have heard of software carpentry workshops, for example. And these workshops form a base from which you build greater skills and more data literacy and more software development skills. So that brings me to Ocean Hack Week. And if you follow the link, you'll learn it's a small, interactive, hands-on workshop. This year it's virtual. And it'll be in 1 week in August. And unfortunately, our application period closed already on Monday. And so I can let you know, though, if you didn't apply this year, that we do have a proposal in for next year. And this is my first year participating in Ocean Hack Week. So let me drop a link to the team so you can have a look at the other folks on the organizing committee. You might know some of the people on the organizing committee. Actually, some of y'all might be on this call. I see a lot of participants here. There's people from Scripps, IUS. Oh, I see Emilio waving at me. Awesome. UW. I think, Emilio, you're at UW. And Bigelow Labs and more. So we have specialists that cross the geosciences, and then this year we're being inclusive of people like me in the biological sciences. So in our breakout rooms that are coming up next, you're going to see there's a discussion question about hackathons. And I wanted to point out that compared to hackathons, which generally are focused on a particular outcome of software development, like you have a use case and you try to develop software for that use case, Hack Weeks have a greater focus on learning and community development. So let me drop, this is the last link, well, actually next to last link I'll drop in. This is kind of a definition of what discriminates a hack week from a hackathon with this greater focus on open-ended projects. And I think that's really important because the hack week is a great way to meet the scientists and students where they are. They can bring in their own project to work on, or they choose a project that's really relevant to their research to work on. I see a question in the chat. Oh, looking for any helpers for Ocean Hack Week. So great, thanks, Emilio. Yes, this year is virtual online, and we all know that you require a lot of helpers and the kind of technical assistance as well in the background. So the last thing I want to post is a link to the playlist from last year's projects if you want to have a look at some of the project demonstrations from last year. And yeah, I guess we're going to go to breakout rooms, and this might be something we want to talk about in terms of workshops or hack weeks connecting informatics to scientists.
Hey, thanks, Stace. That was a lot of really good information. Also, if you can add those links into the Kiko chat so that we have them all documented in one place. There's an additional resources section you can add all those in. Thanks. Okay, so before we go into the breakouts, let me tell you kind of like the idea behind the breakouts. So ideally, I designed this to be a workshop, and then we became virtual, and so it's a bit more difficult to have conversations. So we're going to do this as individual breakout rooms so that we can have a smaller group of people to discuss, how do we do this bridge between science and informatics? And there in the Kiko and in Sketch, there is a link to these Google slides. Let me share my screen so you can see what I'm talking about. Do this. And here we go. So in Kiko, you've got, sorry, I know I'm sharing Kiko, and if you have Kiko, it's a little bit confusing. So in this breakouts, there is a link to the slides, and these are the slides. So the idea is each one of the breakouts should come up with an action. So how do we do this? So, the action's kind of be like, so what? We know this is a problem. Now what do we do about it? We do have some moderators, so it'll be Ed, Stace, Carolina, Steve Diggs, Karen Stocks, myself. But I think there's only 6 of us, and I was going to try it. I think we've got like 64 participants. And so I was thinking maybe we could have like 9 breakout rooms. So if you do not have a moderator in your room, if someone could please volunteer and take notes and just make sure everyone who has a chance to speak. Or if people just want to jot down notes in their slide, that's fine. You can do that as well. These actions or ideas can be as tiny and nuanced and low level as you want, or it can be like super grandiose. Like, I'm going to start a university all about data management. That's fine. This is, just to get the juices going and figure out also like where common themes might be. So the idea is at the last 10 minutes, we'll all come back to the main room, and then each breakout will report out what their action is or that they came up with. And then also, like I said before, we'll continue this conversation in the ESIP Slack channel, Informatics to Science, and figure out like, what do we do with these actions? What comes, what's the next part of this? There is on this next slide, these are conversation starters. Do not feel obligated to answer these questions. They were just, icebreakers in a way to kind of, get the juices flowing, get the conversation started. And I see some of you are already doing this. That's fantastic. So each breakout can copy this slide and work from there. And then this way, you don't have other groups interfering, like, because when you do Google Docs, like, all of a sudden you've moved 10 lines down because other people are typing above you. You won't have that problem with the slides. Or if you're more comfortable, you want to put it down in the doc that's in Kiko, that's fine. Just at least put in a slide saying that's what you're doing, so we know that we have notes in both places. Okay, and Megan and Zachary are going to be the ones helping out pushing us into the various breakouts. And so I think we're ready to do that. So Megan, if you want to
Yes.
do your thing.
Can you remind me the breakout leaders again?
So Stace, myself, Ed, Karen, Steve.
Okay. Give me 1 minute. Keep talking.
Okay. And we're gonna be in the breakouts until when does this ends at I'm sorry, I'm in West Coast, so I'm like doing Pacific time. For me it's 11:50 and we're going till 12:30. So we'll be in breakouts until 12:20 and then or maybe we'll do like maybe 12:15. No, that's not enough. We'll do 12:20 and then everyone reports out on what their action is.
So half an hour in relative
Yeah.
time.
Yeah. So I figure, as people, that's probably that I hope is enough time people settle down and get the conversation going and can come up with an action. And if you want to do it as someone moderates and a separate person does the note taking or recording, that's perfectly fine. It's kind of however you guys want to do this. And if for some reason, like, if the breakout you're in isn't quite like you don't feel like you necessarily match up with the experience level or the topics being discussed, you can jump breakout rooms too. Like if you go on the very bottom of your Zoom, should be a breakout thing and you can hop rooms, but we don't have labels, so you don't really know where you're hopping to. So it could be like a whole musical chair thing.
Like you can't hop rooms. Come back to the main room and I'll put you there, but nobody else run away.
There you go.
This isn't scary.
Yeah, please don't run away.
And so if moderators, if there are 2 of you in a room, just come back to the main room. I think I got it right, but I've messed it up. Okay. How long?
So you're being assigned, Megan's going to push you into a room. So
30 minutes.
30 minutes, yes. 30 minutes in a room with people you may know or not know.
All right. See you all soon. Pierre, or no, Alexander, Kevin, do you want to go into a breakout room? You may have a pop-up inviting you.
So, the question is, what do we do with all of this? Okay, do we have most people back? About 48 people back. I think we can start going through. I think it might be easier if I just share my slide maybe. And then each room can, someone from each room can report out. It looks like Carolina's group is still working on theirs though. So I won't pick on theirs first. Share. Okay, I believe I'm sharing. And okay, so let's go to, we'll go back to, they're still writing Carolina's. Should we go to Stace? Is Stace back or is someone from Stace's group?
Yeah,
You
I'm
want to
here.
Okay, do you want to report? Like, we're just going to list real quick since we only have 7 minutes left.
Oh, yeah, sure. So our room focused on how to reach out to practicing scientists, and we had 2 nuggets, 2 action items at the top. And one was to encourage small steps towards best practices by sharing just nuggets out of our informatics expertise and documents, and apply those nuggets to real science examples so that the value to the scientists is clear. The value to the scientists and their science is clear. So
Nice.
thanks.
Okay, thanks. So in my breakout room, we came up with 2 because both were really good. So one is this idea of having data science education and training, something hands-on for grad students, or like the Hack Week things that Stace and other people are involved with. We really like that. And also that all repositories should have a common forum or hub so people can ask questions, kind of like having a year-round data help desk thing. Okay. And then Ed, do you or someone from your room want to report on yours?
Yeah, okay, here's Ed here. Hello. And so our action item there is kind of listed right at the top there, is to develop analogies to simplify complex subjects, right? And bring analogies to new communities, right? So that's one way of beginning to bridge bridge informatics and science and the most complex informatics techniques to new scientists that are working on similar problems, but perhaps in a different discipline. So it's not that hard to do once you develop the proper analogy to simplify the complex. That's our main action. But we've took a lot of good notes there on different types of subjects, all great stuff. So
Okay, cool.
I developed several more action items.
Yeah, thanks. So room 7, Karen.
Yep. So our action is the idea of SciData pop-up labs, where at ESIP we could develop a framework for institutions to implement or create these brainstorming and co-design sessions where scientists, ideally early in a project, but not necessarily limited to it, kind of talk about what they're trying to do and why and how, and IT experts can sort of say, oh, well, you might want to connect with this group over here, or maybe have you looked at this tool, but it's important to us that it's framed as sort of an equal brainstorming session and not as we're an expert telling you, the scientist, what to do.
Mm-hmm. Nice. Okay. Breakout room 1. So Matt, Tamar, Doug, Elizabeth, other Doug.
I guess my group nominated me to talk about this, so here I go.
Do it.
One of the conclusions that we came to was starting data management early in the career, potentially making courses at the undergraduate or graduate level, and make part of the required curriculum. Probably not something ESIP can accomplish, but it's something that we should look forward to, as well as getting basically getting scientists more involved in the data management process by having robust data management consulting, which facilitates advocates in our community, and looking at senior management to include data management as recommendations/requirements that would connect out the policies to kind of go as the top-down approach.
Nice. Thank you. Okay, breakout room 4. I don't see your participants, but they said something about GSA and local meetings.
Can I actually
there you
jump
go. Excuse me?
Can I jump in? It's Carolina.
Oh, yes. Let me go to yours.
Sure.
There you go.
Actually, like what we talked about and what we found mirrored what Matt's group suggested almost exactly. That, you know, when you start to find solutions at the data center level, it's, you know, it varies widely by the size and the scope of the data center. And so the best approach is really to reach scientists to create data that is ready to go into this pipeline. And so the efforts, we kind of, Matt mentioned like creating courses. So someone in our group actually had knowledge of a course that's maybe going to be available online, which is like an undergraduate course. And it was interesting that people don't necessarily take it unless it's required by their PI. So maybe that's kind of a way to move forward. And that kind of there was two components to getting scientists involved, which was one, to kind of foster enthusiasm, and then also to share information on how to do it once they're willing. So yeah, it was almost exactly what Matt's group had. Oh, and sorry, when about generating that enthusiasm, and this I think a little bit ties into what Stace said, Sean kind of put forward this idea of creating user stories of success, like success stories of when a scientist was able to do something with their science because of proper data management. So maybe like some kind of central resource of a collection of these user stories would be something to look into.
Thank you. Yeah, we're running out of time, but I want to get through all the groups. Breakout room number 4, if you can do it in, you have a lot in here, so can you give it in a sentence?
Well, we actually, this is Frank, we just went over the conversation list, so meetings for GSA. I think one of the key things is that it would be good also to involve different, not only junior people, but also like, more senior people who don't often have experience with data management, and they have to be addressed maybe differently, but not everybody's using Twitter, so it was one of the things, but maybe bring them together in webinars or have maybe panels where people can talk about their experiences would be good. And reaching out to other informatics groups outside the science community would be a good too. Maybe we don't have the time to go there, but RDA, some people said they produce a lot of good output that may be useful for our community as well.
Okay, thank you. Breakout room 5, Aaron, Ted, Peter, Mike.
I took the notes. I think we like the idea of getting going early and also mixing, being in situations where you mix with people from the other side. And I just wanted to point out there's 2 things going on at this meeting that were meant to facilitate that or help facilitate it. One was the email groups that went out earlier in the week that sort of took random diverse collections of people at ESIP to try and get them into the same room. And then also the Hangouts. I don't know how many people have tried using the hallway Hangout or the conference dinner Hangout. Those were ways, tools created at this meeting to try and facilitate that kind of cross talk between scientists and technology people. So it would be interesting to see how well those might work.
Okay, thanks, Ted. And also, if you can put it in the notes, I guess I know that some are emailed, but like maybe the links for those Hangouts for like the dinner chats and stuff like that, that might be useful. Okay, Steve's group.
Megan can do that.
Okay. Thanks, Megan.
For breakout number 8, I think I heard this from someone else's group. One of the the things that came out in our group over and over again was a statement about values that were not very clear in our community about what the values are. The values for the science we support, as well as the value of adopting things. Another point, and I brought this out from listening to the people in the breakout group, is that we don't promote the use of these tools, adoption, best practices as improving science. We don't make a clear case to science. If we're talking about connecting earth scientists to informatics, the number one thing to hear is it will increase your funding, and the number 2 things is it improves your science. We talk to ourselves too much about incremental improvements in vocabularies and semantics and other things, but what we really need to do to connect better is to have a clear set of values and a clear set of talking points about improving science. One of the other things that came out that was from other groups as well was the materials for early career, getting these ideas in early. And this is a chance to promote next week's session. I have nothing to do with it. Things I wish I knew in graduate school, which talks about data management for people in their early career. And I think that that's worth attending and talking about.
Nice. Thank you. Okay, so last one. Oh no, or is that just a continuation of yours, Steve? That looks like it's just another one of yours. Okay, cool. So it sounds like most of us have said like we want to get to students. We want to get them. We want to make sure that we communicate with them early on, but also we need to improve our communication with scientists and show them that their science is not in jeopardy, but rather it can be improved and be done more efficiently. So that's great. And so, like I said, we will continue this in the Slack channel. I'm going to try to consolidate all these notes because I'm sure there's more than just like the 2-sentence reviews everyone gave. And thank you all so much for participating in this. I'm very glad that there was a lot of conversation driven from this, and also there's very, I think, doable things from these as well. So thanks everyone, and thanks to the speakers and moderators. Yes.
Hey Jessica, Julie Lowndes, who was with us earlier in the plenary, was in this session for most of the time before we went into breakouts, and I know she was having a great time. And I think her approach, the cohort approach and the longer term cohort approach, is also good. And I think she's going to do great stuff in OpenScapes in the future.
Oh, absolutely. Yeah. No, I mean, this whole movement toward both plenaries this morning I think were fantastic and showed what open science can do, but also what happens when we bring communities together in a common space.
Yeah. And this room stays open, so it's not like we're going to get yanked out of this room.
Exactly. Like if people want to hang out, we can totally talk about this more. But people have lives as well. I understand that. So this will be the official end of the session. But if you want to hang out and talk about this more, I am happy to.